Okay, so thank you, we've got these values that we call powers. Okay, so this is basically one of the examples that they were talking about. This is 5 to the third power, or they also used another word. Anybody recognize what other word they used in the video? Veronica? Cubed. Okay, they also used the term cubed in the video. So that is just another way of saying a different power. The only other one that has a unique way of saying its name would be the second power. Anybody know what we call a second power? Bridget? Squared. Okay, and then that kind of makes sense because if we go back through with our geometry units, area is based off of two-dimensional figures, squaring. So kind of a square is a two-dimensional value. And then you've got volume, which was based off of three-dimensional units, so a cube. So cubing values. Everything else we basically just say to the first power, to the second power, or to the fourth power, to the fifth power, and so on and so forth. But when we're looking at these, the 5, this 5 is called a base value. So whenever you hear me talking about the base, that's what I'm talking about. It's the larger value, the component. And then the small little itty bitty value that's written up in the corner is called an exponent. And the combination of these two create a power. Okay, and like the video said, that exponent is going to tell us how often we repeat the base in a multiplication problem. So it tells how many times the base is used as a factor in multiplication. Okay, how often that base is going to be used as a factor in a multiplication problem. So this is basically 5 times 5 times 5 because we're using that base 3 different times. Okay. And like I said before, when we're writing these down, they each have their own terminology. The way that you state it, 5 to the first power. Now, every single number, if you turn back again to that board in the back where it says invisible math, if everybody turn around to the invisible math board, in the back, you'll see the very first top green paper. It says 7 is equal to 7 with an exponent of a 1. Every single number has an exponent. If it's not written, it automatically has a 1 as the exponent. Okay, it's just the same as every variable has a coefficient. Even if it's not written, it has that invisible 1. Okay, same thing with numbers. Every number has an invisible exponent. It's just a 1. But the way that we would state this is we would call it 5 to the first power. This is 5 to the first power. And again, this would be 5 to the second power. Or more commonly known as 5 squared. This is the more common one. All right, this one, again, we would call it 5 to the third power, or more commonly known as 5 cubed. And then it just keeps progressing on from there, 5 to the fourth, 5 to the fifth, 5 to the sixth, and so on and so forth. Okay, and we've got 2 ways that you can write these problems out. You can write in what's called standard or expanded form. So actually I'm going to even write that down. Standard form is also known as, so we'll say AKA, expanded form. Standard form is also known as expanded form. And then you've got what's called exponential form. Exponential form is when you simplify it where it is a single base and a single power to that base. So for example, standard form or expanded form, I could write 6 times 6 times 6 times 6. That would be an expanded form or standard way of writing it. In its exponential form, it would be 6 to what power? The 4th power. So 6 to the 4th would be that exponential form. So what we're going to do is we're going to write the following values into exponential form. So I want you guys to do the first 4 on your own. Let's see what you can do. Go ahead and do those first 4 on your own. Take these expanded forms, put them into exponential form. All right, for problem number 1, who can tell me what they wrote for 4 times 4 times 4 times 4 times 4? Armando. 4 to the 5th power. So you wrote it like this, 4, and then to the 5th? Okay, that's good. Number 2, we have 3 times 6 times 3 times 6 times 6. Who can tell me what they wrote? You turn? Your turn? 3 squared times 6 cubed, like this? Okay, that's correct. So we have different bases. We have a base of a 3 that occurred twice, and then we have the base of a 6 that occurred 3 times. So we have different bases, so the power is going to be written out a little bit differently. What about for problem number 3? Who can tell me how they wrote number 3? Alex. So you wrote it like this, -2 cubed? Yeah? Why did you put parentheses around it? Anybody else put parentheses around theirs? Raise your hand if you didn't put parentheses around it. Okay, so you do need to put parentheses around them. And there's a reason why. For a problem like number 3, it won't have an effect on it. That's not that big of a deal if you did or did not. But, here off to the side, let's say that we did something like this. -4 to the 2nd power without parentheses is not the same thing. It's not equal to -4 that's in parentheses raised to the 2nd power. Why do you think that that is? I want you to take a moment. I want you to think through. Why do you think these are not going to be equal to each other? Think through it in your head for a moment. Come up with a reasoning or a hypothesis. Okay, now I want you to share with the partner. What did you think was the reasoning why they won't be the same? Talk it out. Talk with your neighbor. Okay, bring it back in 3, 2, 1. John. Michael. What do you think is the reasoning as to why they're not the same?
For the first one, since a negative times a negative is positive, I'm guessing the second one is like a negative times or something.
Close, but it's actually the reverse. The first one would be like a negative times a positive, almost. The second one would be the negative times the negative. See, what's happening here, when you have the parentheses around the -4, not only is the 4 getting the exponent, but so is the negative. the negative is also part of that repetition. For here, the first one, only the 4 has the exponent of the 2. So the 4 is the base, the negative is not. So essentially when you're writing it, guys, it's almost like you're saying a negative of 4 times 4. Well, what's 4 times 4? 16. So you're saying it's a negative of 16, which is negative 16. Here on the other side, so again, like I said, these are not going to be equal to each other. For this side, you are actually repeating a multiplication problem of that negative value. So you are doing negative 4 times negative 4. And negative 4 times negative 4 is a positive 16. They're not equal to each other. So when you've got a negative base that's being repeated, you must include parentheses around that base when you put it in exponential form. When you don't include the parentheses, you are stating that the answer you get is going to be negative no matter what. Versus if you have it in parentheses, it might come out to a positive. Okay? What about for problem number 4? 2/3 times 2/3 times 2/3. What did you have, Bridget? 2/3 cubed. Okay? Like that? Yeah? That is actually not the same thing. Why? What do you think we need? Parentheses. Because again, 2/3 times 2/3 times 2/3. What do you think this is going to look like if I were to put it in expanded form? If I were to just put it like this, what do you think in expanded form that would look like? Alex?
In expanded form would be
2 times 2 times 2 over 3. That's what that would look like. When you have, oops, sorry, I meant putting it cubed. My bad. 2 times 2 times 2 over 3 is what it looks like when you don't have the parentheses. When you do have the parentheses, that means that the entire fraction is being repeated in the multiplication. So parentheses, guys, is super important when it comes to working through your powers. Okay? Any questions? All right, let's go on over to the back paper. Want to make sure we include those parentheses. So based off of including the parentheses, you can now go through and work these out. If we were to write this out, this has parentheses around the -5. That means that in expanded form, this is going to be -5 times -5 times -5 times -5. And what do we get when we work that out? 625. Good. Positive 625. Okay? I want you to do problems 2, 3, and 4 on your own. Do problems 2, 3, and 4 on your own, please. All right, let's go ahead and go over this. So for problem number 2, who can tell me what does it equal once you've simplified it? What is it going to equal once you've simplified? When we've got 6 over 7 inside parentheses and it's raised to the second power or it is squared. Bridget? 36 over 49. You are going to legit just multiply 6 times 6 over 7 times 7. That's what it is. And 6 times 6 is 36. 7 times 7 is 49. You get 36 over 49. Now, alternatively, if you've got 6 over 7 without the parentheses and it's squared, what will that equal, Armando? 36 over 7. That just comes out to 6 times 6 over 7. 7 does not have the exponent involved in it. 6 times 6 being 36 over 7. Okay, you could leave them. You can leave them as improper fractions. It's perfectly fine because when we progress into our units second semester, you will no longer be doing mixed numbers. at all. So I want you guys to not focus on mixed numbers right now. Keep them improper because it's important that you keep things improper for our units in second semester. Okay? All right, problem number 4, we have a squared plus b squared, and we've got a equaling -3 and b is equaling a +5. What is that going to come out to as our answer? Yo-chan? What'd you get? 16? Not 16. Somebody besides Armando. Come on, guys. Everybody should have been working through this. Dylan, what did you get?
The actual answer?
Yeah.
I only put like the equation.
Well, what did you put for your equation?
-9 plus -25.
Where'd you get negatives?
What's in right there?
But that's -3, which is A. A is being raised to the second power, right? So -3, the whole thing, -3 is being raised to the second power. What's -3 times -3?
Wait, no, 9.
+9. And then 5 times 5 is definitely not negative. So +25. Right? And what's 9 plus 25, guys? 34. Okay? So here they're saying A, the value of A is being raised to the second power. Even though they don't have parentheses there, they're indicating to you that A, whatever A equals, that is being raised to the second power. So since A happens to be a negative value, that whole thing is being raised to the second power. So -3 in parentheses to the second power is going to come out to a +9. Then you've got B to the second power. B happens to be a +5 to the second power, which is 25. And when you combine those two values together, that's going to give you the 34. Okay? On Google Classroom, you have 4 IXL skills. They're quick and easy, guys. They should not take you very long. In fact, you should be able to finish it before class time is done. Anybody who finishes before class time is done with all 4 IXLs will get a piece of candy. Now, after, hold on, one more quick note. Shh. On Prodigy game right now. In fact, let me stop the video.